Traditional multiple-choice tests are highly efficient to score, but that efficiency has a clear limit. When a student chooses between 4 predefined options, they are rarely engaging in the kind of original problem-solving required to handle complex real-world scenarios. Moving beyond predefined answers requires a different measurement approach entirely: performance assessment. In this model, instead of selecting an answer, the student must construct an original response, generate a specific product, or execute a behavior. This staircase graphic maps assessment options to the real-world behaviors we want to measure. Look at the bottom step. True-false questions require almost no original construction. But the highest step, placing students in groups to solve unencountered problems, directly mirrors authentic capabilities. Tests do not gain rigor simply by replacing multiple-choice bubbles with short answer blanks. The validity of a constructed response test depends directly on how closely the required task approximates the authentic behavior we care about. There is a persistent professional misconception that assigning any essay or short answer prompt automatically constitutes a rigorous performance assessment. It does not. True performance assessment requires 3 strict architectural pillars to function as a valid measurement scheme. The first pillar is multiple evaluative criteria. A student's output must be judged on several distinct vectors simultaneously, like accent, syntax, and vocabulary. The second pillar is pre-specified quality standards. The specific rules determining a successful performance must be explicitly defined in advance. The third is judgmental appraisal. Unlike selected response tests, these assessments rely strictly on calibrated human judgment to evaluate the work. A true performance assessment is an engineered system of human judgment calibrated against predefined, multifaceted criteria. The bedrock goal of all classroom assessment is simple: to make an accurate, defensible inference about what a student has actually learned. This diagram outlines the structural relationship connecting a teacher's curricular aim to the assigned task, and finally to the inferred student status. Look at the middle box. The performance task itself is not the end goal. It's merely the mechanical vehicle used to secure data. If the vehicle breaks down, if the task fails to yield valid representative evidence, the teacher's inference about the student's mastery will be compromised entirely. This brings us to the primary statistical weakness of performance testing, a problem measurement specialists call the generalizability dilemma. It is the inherent friction between deep tasks and reliable data. Consider a traditional math test. A teacher might give a student 20 double-digit multiplication problems to solve in 30 minutes. Those 20 answers provide a high sample size. With 20 data points, the teacher can confidently generalize whether the student possesses the underlying skill of multiplication. Now replace those 20 problems with a single complex problem, requiring the student to derive an original mathematical solution using physical manipulatives over that same 30 minutes. Your statistical sample size instantly drops to 1. If the student produces an excellent solution, does it prove they possess the broad category of skills being tested, or did they just get lucky with that specific prompt? Conversely, if they fail, did a confusing element in that single task mislead an otherwise capable student? By sacrificing statistical sample size to achieve task depth, educators drastically reduce the data points available, making it significantly harder to safely generalize a student's true capability. Educators mitigate this risk through ruthless precision in task selection. Because you only have time for a handful of performance tests, the tasks you choose must carry maximum diagnostic weight. To vet potential tasks before they reach a classroom, measurement specialists rely on these 7 evaluative criteria. The first 2 are the most critical. Generalizability asks whether success on this specific task reliably predicts success on comparable tasks. Authenticity demands the task mirror encounters in the real world, rather than existing merely as an artificial school exercise. A performance task is only worth the immense time it costs to administer if the behavior it demands acts as a reliable, authentic proxy for broader skill mastery. Even a perfectly selected task is completely useless without a valid tool for judgmental appraisal. That tool is the scoring rubric. A functional rubric must contain 3 features: the evaluative criteria used to judge quality, the qualitative descriptions defining the differences between score levels, and the scoring approach. That scoring approach toggles between 2 methods: Holistic scoring requires a single overall judgment, which is fast but lacks detail. Analytic scoring awards points criterion by criterion, providing the high diagnostic feedback students need to correct their specific errors. The evaluative criteria chosen dictate the entire assessment. If you select flawed criteria, your measurement fails, and your instructional planning suffers. Many educators assume that any grid of expectations is a valid rubric. In reality, the majority of rubrics currently deployed fail to measure what they intend, falling into two structurally deficient categories. The task-specific rubric grades hyper-specific details, like mentioning firefighters, restricting skill transfer, and forcing instruction to the prompt. The opposite extreme is the hyper-general rubric, using vague descriptors like adequate, which fails to illuminate any meaningful path for instructional adjustment. Because both models obscure the precise mechanics of the skill being tested, they provide no actionable insights for future instruction. The solution is the skill-focused rubric. It roots criteria in the skill's fundamental mechanics. Instead of firefighter facts, it demands structural elements, an introduction, body, and conclusion. Because these are conceptually abstracted, they transfer seamlessly to any future narrative problem. A skill-focused rubric goes beyond scoring a test. It actively serves as an architectural blueprint for the teacher's entire instructional sequence. Deploying true performance assessments carries high stakes and high operational costs in time and resources. To use them effectively, educators must embrace a central trade-off, willingly sacrificing the statistical breadth of traditional testing in exchange for authentic depth of measurement. When we engineer tasks for maximum generalizability and we score them strictly with skill-focused rubrics, we align our educational metrics directly with authentic capability. Rigorous classroom assessment is not about efficiently counting correct answers. It is about designing the precise machinery necessary to make defensible inferences about what a human being can actually achieve in the real world.